To many, coding is just a hard skill. It's a logical process where you must follow the rules and you cannot express yourself creatively. And to some extent, this is true. There are rules, and if you don't follow them, you will get thrown an error. However, in this video, I want to zoom out a bit, and I'm going to argue that coding is closer to an art form than it is a conformity. Now, I consider myself to be very passionate about coding, and the chances are, if you're watching this video, you feel the same way. You know that exciting feeling you get when you're building something. And I've kind of struggled to put into words exactly why I get that feeling or what exactly that feeling is. But in this video, I'm going to break down exactly that, why we feel so passionate about coding. Now, I believe the reason so many people are passionate about coding is because of this idea of abstraction. Abstraction is the process of distilling complex code into a more simplified view using modular programming. So you're basically taking some code and then packaging it into a more simplified and reusable version that does the same thing. Let's take the simple example of converting between Celsius and Fahrenheit. The equation for converting between Celsius and Fahrenheit is as follows. You take the value in Celsius, you times it by 9/5, and then you add 32. So if we wanted to convert 10 degrees Celsius into Fahrenheit, we then plug it into this equation, so 10 times 9/5, then add 32, and that gives us 50 degrees Fahrenheit. If we then want to convert a different value, let's say 20 degrees Celsius, we would then plug that into the same equation and do 20 times 9/5 plus 32, which would give us 68 degrees Fahrenheit. Now this is a very simple equation, but every time we want to do the calculation, we have to retype this equation. We can use the concept of abstraction to take this simple equation and put it into a Python function. Now to do this conversion from now on, instead of typing out the whole equation, we just need to call our function. In the same way, we can create a function that does the reverse calculation. So this function will convert from Fahrenheit to Celsius, and instead of writing out the whole equation, we just have to now call the function, same as before. Now this is a very simple demonstration of abstraction, but we can actually abstract further. We can now take our functions that we've just created and create a Python package. That way, instead of defining the functions in every Python file we create, we can simply import the package which already has the functions built into the package. And this already exists in Python. There's a Python package called 𝗶𝘁, which has many functions for converting between different temperatures. So for example, we can convert between Celsius and Fahrenheit back to Celsius like we already have done, but we can also convert between other units of temperature such as Kelvin. So Kelvin to Celsius, Celsius to Kelvin, Fahrenheit to Kelvin, and Kelvin to Fahrenheit. And these are all pre-built in to the 𝗶𝘁 package. So we've started by using an equation which converts from one temperature unit to another. We then abstracted this into its own function, and then we're basically pooling multiple functions into a package. So we've basically got 2 or 3 layers of abstraction here going from the raw code into the functions into the package. Now anytime you want to do temperature conversion in a project of ours, all we have to do is load in the package, the pre-existing package. We don't have to reinvent the wheel, so to speak. As well as abstracting code into functions and packages, we can also abstract code into pipelines, APIs, and whole standalone software. So remember, all we're doing is taking some code and then packaging it into a simple form that's more reusable. Now, abstraction actually goes both ways. You may think we're starting just from the programming language itself, but we can actually go even smaller than that. We can go all the way down to the level of the transistors in our circuits. So transistors are used to represent binary digits by either allowing electricity to pass through or not. The presence of electricity can represent a 1, and the lack of electricity passing through can represent a 0. This is what we call binary. We can then combine binary digits to code for larger numbers. For example, if we have 3 transistors, we can represent the numbers from 0 to 7. Transistors can also be combined into logic gates. A logic gate is a basic building block of digital electronics that takes one or more binary inputs and produces a binary output that's based on a set of rules. It's basically like a switch that either allows an electric signal to pass through or not, based on the input signals. These logic gates can be combined to create digital circuits which can perform more complex operations. So for example, memory chips and processors. On top of these, we then have our programming languages. So programming languages, as we know, are written in human readable text. But to actually send instructions to the computer, it needs to be translated into machine code. So the programming language is kind of the interface between us as the humans and the actual computer itself. So as you can see, there's many layers of abstraction here. We start at the smallest level, and then we iteratively add more and more complex layers of abstraction. It's kind of like how atoms form molecules, which form living organisms, which form ecosystems, which form the planet, the solar system, galaxy, universe, and so on. We're just adding layers of complexity. Now, the reason this is so powerful is that we as the programmers do not have to reinvent the wheel. We don't even have to understand how the wheel was built. For example, we don't have to actually wire up the transistors ourselves in these computer chips to be able to write programs. We are basically building on layers of abstraction that have already been built. Now, this gives us massive leverage in what we can build. We're basically standing on the shoulders of giants in the sense that we're just building on top of what was built before us. And I think this is what gives me and so many others such a passion for coding. There are unlimited possibilities of what we can build. And as time passes, there's only going to be more opportunity as more abstractions are built. As I mentioned, we don't need to understand fundamentally how an abstraction works to be able to use it. Take ChatGPT, for example. OpenAI, the company that created ChatGPT, they've now released an API which allows you to use the GPT model in your code. This means we can just build software using this highly advanced AI model with just a few lines of code. We just import this OpenAI package and we need to get an API key. But aside from that, we just set a prompt and then we call the prompt, and with just a few lines of code, we're using this AI model in our software. We don't need to understand how the model was built or how it works under the hood to be able to make use of its incredible functionality. How powerful is that? And the GPT model is an abstraction itself. It's built using Python, using packages such as PyTorch. And it's basically an abstraction built on abstractions, built on abstractions. And kind of what I'm getting at here is that there's kind of unlimited upside. Like we're building on top of what's been built, and then we're building on top of that. And in the future, I can't even imagine the type of things we're going to be able to build. Because even right now, with the huge advances in AI that we're seeing, like 10, 20 years from now, that's going to be nothing. Like the things we're going to have 10 or 20 years from now, it's going to be crazy because we're just iteratively building on top of things. This is what gives me such a passion for coding, because I'm just a guy who's taught himself how to code. Yet I have access to these incredible tools basically for free. Maybe you have to pay for the API, but you get free credits so you can play around with it for free. But what I'm getting at here is like there's so much potential to build things. Like I can literally use this AI model in my own software. I can use different, like there's hundreds, thousands, probably millions of software packages available that you can just import and use. You don't have to create anything yourself. You can just use what's already out there and build on top of it. And that's what gives me this such an excitement for coding. So to conclude this more philosophical video, coding is not just about following rules, but it's about creatively solving problems through the power of abstraction. And with each layer of abstraction, we're opening more doors to creating some crazy and cool and wild and wonderful things. Coding is not bound by the limits of our understanding, but the limits of our creativity. Thank you for watching.